make our pusher, and of course we have two blanks that we've cut off already, and we're going to be milling the slot to put in our own shape here. So we kind of need to know what kind of shape to put in there, and we've went ahead and a combination of a couple different tools, we were able to go ahead and create a drawing. Alright, now the first thing we did was we were playing around with our bevel protractor, and we were measuring from the top and down the side so we get kind of an idea of what angle it is, because this is an involute spline, meaning these splines are not straight up and down on the side, they angle in. Alright, that angle kind of just by a quick eyeball, no light behind it, and no magnifying glass, which we're going to do a little bit of math from our other source there, and we're going to figure out what the actual angle is. But by the bevel protractor, it looks like it's right close to 22 degrees. Alright, also we had our monkey shit, and this is basically so that we have a quick mold and that we can play around with creating our shape down in here. And of course we want to have a little bit narrower tool and then go side to side, and this kind of gives us a quick visual of what we're actually looking at when we go to sharpen up a tool bit there, and it gives us a quick reference to go ahead and play with as far as by eyeball. And then the next thing we did is we went ahead and took our gear tooth veneer, the next thing we did was take our gear tooth vernier calipers, and we came into the width of the root and then came down from the top there, and we basically got 312 thousandths at the base and about 165 on the depth. After we did that, we went ahead and took our dial calipers, and we came up and we rode them up the side of the taper until they finally came together, and we were watching our dial, and we basically come up with 210 thousandths for a width on the top there. So by knowing the three factors there, we're going to draw this out on the little paper there, and we'll be able to actually calculate that angle right on out, and come up with that as far as being able to set up and then grind it equally on both sides of our tool bit until we get a shape that we want to have on the high-speed bit, and then we're going to cut it off the length and then silver braze it to the end of our shaft. So that's kind of the plan we got going right now. We went ahead and we took our flashlight, we nitpicked looking at there, and we do come up with 22 degrees of angle per side. And we noticed that we were up on the radius a little bit. When we had the flashlight, we could see that actually we were measuring at like 312, 5/16, and it was closer to being like 330. And this was radius at the top there, so the whole height and everything else is pretty about 200. That figured in with what we saw with the angle there, and then we drew it out on our plasma cam because we have that capabilities of laying everything else out there, and put the line up there, and the line measures out 22 degrees. Alright, so basically that's what we're going to put in on this tool bit here. Just a little highlight on tool bits. This is a no-name, like you would in almost a rough finish, and it mics up about 2-3 thousandths larger. Somebody's just ground something on this one here. It might even been me, just to go ahead and give it an angle there to come in and kiss the chamfer or something in a single setup. All right, and I just broke that edge there, it looks like, or whoever did it. This side is virgin, and you can see how most high-speed steels will have an angle cut on the tip, and the reason why they do that is that automatically you're going to have some kind of in relief on almost every tool that you fab. And so of course this is quite steep here, and we're going to also dress it off clean. Now we're going to be basically just grinding an angle here and an angle here on each side here, and we have our grinder set up across here from you. Alright, now under here is the angle of the table. Now right now they're both set at 10, and that's kind of just a rough grind that I have, because I like to have, especially if I'm going to grind a brazed tool bit, I tend to knock the softer material away steeper, and then I go over to the carbide one, and then I'll dress the carbide at a little lesser angle, because the whole theory of the tool bit being pushed across there, okay, all you need is just enough relief. If you have excess relief, it makes your edge on the cutting edge or your leading edge sharper, and it also becomes less reliable. It will wear faster. Okay, the less that angle is, the more it has to go rubbing and creating friction and wearing on your surface to dull it. All right, so less angle, stronger, longer lasting tool bit. All right, now because we are working straight lines, I don't need a whole bunch of side relief, so we're going to go ahead and we're going to adjust this, and I'm just going to go ahead and give this give it about 6 or 7 right there. Okay, that's still a good amount, just slightly less than what's normally on the end of there. All right, we're going to do that to both of them. We're doing this as a mirror image project here. Alright, and double check it again. I turned it sideways so it's actually flat and I can actually physically see. And you turn it that way and it's pretty darn close, a little bit less than that. Alright, both of these protractors I got set for 22 degrees. Both of them locked, both of them are angled back. Alright, now I'm going to go ahead and move your viewing position down so you get to see. But basically I'm going to take my regular parallel, and I'm actually going to hold that against here, and then it's going to give me that reverse plane to where I can take the tool bit and feed it in and grind on that side, come over here, mirror image it, and grind on this side. We're going to start on this side here, and we're going to work it on what we call the top, and that's going to be called the top. Now remember, we're only going to be a little bit around 165 on our depth, okay? So this measurement of grind here only needs to be 165 plus a little bit. We just always want to keep a little bit of cutting area up here. Okay, that's pretty good. Okay, we're going to go to the other side, and we're going to knock a little bit off of this other side. Switch hands. Sometimes that's a good thing. Keep moving your bit. Okay, now I'm just looking for that width to be about the same on that side as that is on that one. And I'm able to keep this in even though I let it flex back and forth. I'm still working that angle. I'm moving this again because I just didn't know if my fat head was in the way or not. Alright. I'm just setting my parallel out of the way. I want to actually look and see. 160. About 160 there. Total straight depth, about 150. The width across the front here, about 140. Alright, we're going to take her a little bit more on both sides. I want to make sure that I have the depth okay, that definitely is long enough there. Alright, I'm going to kiss it on the other side. Okay, I'm going to get a small square so that I can hold it and I can see this leading edge and that leading edge there. And by eyeball, I'm going to make them even. And then we're going to go for dressing off the nose piece here. Taking my precision square here and taking a glance at both sides. Okay, I'm even with it on that side, and this side here looks like about another 10 thousandths. So I'm bringing it over here, and I just want to take another 10 off of it. Alright, we're going to approach this real slow. A little bit more. Alright, I like that. We're pretty even. Now, straight in depth here, it almost looks like about 180. And I need to be square. That's a little bit less than the stock grind. And now I hold that up so that I can see the light behind it. And I need to be slightly angled this way here. Ever so slightly. Alright, I like that. Alright, I'm just double checking depth here. Like 190 thousandths or so. Alright, now I'm going to stone this. And then I'm going to be happy with that angles and everything else. We got a V-block clamped in here, and we get our rod pushed in here. We're going to do 2 clamps on here. All right, and we'll take the Allen wrench here and put them in there and snug those up. We know it's not going to go anywhere. All right, now we want to locate this pin so that we're going to be center line with it. We're going to go ahead and pop in our coaxial indicator. Just convenient because we're using a 3/8 collet for our tool bit, and that also is what the coaxial indicator uses here as well. And I like to use this reach around here. And let's get it in neutral here. Okay. Alright, now we're going to bring it down around here, and then we'll spin it around Alright, close enough. We're going to turn it on. Alright, I like her there. Alright, we're going to call that close enough to being 0 or center with that rod. And I locked all the tables and everything else. And now we'll double check it. Just because I know that when I lock my tables, it does make a difference, as you just saw. Okay. Alright, now we got our end mill in here. And we're going to go ahead and raise our table up after we tighten this end mill. Alright, we'll go ahead. We're going to set 0 on our depth. Alright, and we're going to go ahead. We're going to take 1/8 of an inch. This one here, we're going to go down. Of course, we're going to have the hole. Alright. We're going to take it down to where we get this to fit in here. And we have it almost all the way up to the top. Maybe, I don't know, maybe 225 thousandths or something like that. Just shy of the, so the whole tool bit will be facing out on the outside, but the sides will almost come up and wrap around the tool bit. When we silver solder that in there, then it's going to be a much stronger hold for the tool bit. I'm just feeding it gently across there. You can see that the chips are real white. Even the little burr that comes off the other end is still white, so I'm not overheating anything. Alright, this is 200. I'm going back the other direction. This is not a precision slot. This is a little bit of clearance even, because you want silver solder to flow in there, and even the turbo cut on the side will give a little bit of holding strength. And I'm not using any cutting oil and stuff like that, just because I want to keep it nice and clean for a silver solder job. I'm going to see if this fits in here at all. And it doesn't. But I didn't expect it to. The tool bit is roughly a little wider than 1/4 inch. Alright. That was like 200 on the depth there. Okay, we're going to go down to 225. I think that's going to be great. And I'm gonna step this to the side about 5 thousandths each way. Okay, 5 the other way. Okay, little air. And our tool bit fits in there. Pretty good. I like that. Alright, let's just check it in the right direction too, because I might have been laying it sideways. That's perfect. Okay, let's go ahead and do the other one the same. Alright, back to 0. Fits right in there. We're going to be doing a little tiny bit of filing and deburring all the way around the whole edge here. Alright, and just for, let's see what we got, 117, 117 and a half. Kind of, I mean, this affects it over here. 118, 16, 17. Yeah, if you jiggle it till it goes lower, I mean, finds the lowest spot in there. But we're within a thousandth of each side there, so we're pretty center. I'm happy with that. All right, we're going to go ahead and deburr this, and we're going to get this tool bit set up in there. Alright, I'm all happy with, I deburred all of this, and we're going to go ahead and radius these corners slightly so that it'll fit all the way down in there. There's just a little tiny bit of a gap right at the underside there. I've got this marked off. Now I'm going to go over and take my abrasive cutoff wheel, my little 3-inch pneumatic cutoff wheel, and put it in a vise, and I'm going to cut this off, and then I'll go dress the rest of this in the grinder. Alright, I know you guys have all seen me silver solder before, and here's our tool bit ready to go into here, and we have a little bit of clearance in there, but this thing is going to be centered and held straight, and we'll be able to align this because we got this sitting out slightly, and we'll be able to square it as well. Alright, we got to get some flux in here, and of course I like a Q-tip there, or a screwdriver. Just because my fingers are starting to get a little fat. Alright, so we rub that all in there, and this is the bottom. So we make sure that we're painting the bottom and the two sides. Alright, and we want to put this in here flush with the end. Something like that. Now the other end of the Q-tip, we'll go ahead and just wipe that excess right off of there, off the top face there. That looks good. Okay, just in case we need something around, just to push on the top there, and this 1/4-inch rod will be able to do that. We'll keep that handy. Alright, we don't want to lose that. That's our ground off piece of tool bit there. We want to make sure that doesn't get knocked into the trash. And we haven't used our small bottles in a while. Alright, nice calm flame. This ain't going to take a whole bunch of heat. I'm just trying to focus most of the heat to the back side here. And we can add a little bit of heat to the sides, letting the silver solder flow in on both sides. Yeah, I think she's pouring in there pretty good. I'm gonna just get it warm here once and hold down on this. Okay, we're gonna let her cool, and we'll go clean her off and take a look at it. All right, I'm gonna hold this up for you. Hopefully, we got a good view there. All right, you can see the silver solder is really dripped out around here, and you can't see too much along the front, but that's good. I like that sharp edge right there. It lets us, after we wire wheel clean this, it'll give us a straight edge so that we can set this with a square or vertical or horizontal. Also, the silver solder has come all the way through and flow right underneath the front, and you can also see it, the leading edge where it climbed up both sides. Alright, we're gonna have a good solid bit right here. Alright, and still nice and sharp. We're gonna be able to stone that surface right there, get a nice smooth edge on it. Alright, I'm gonna go wire wheel and clean some of this silver solder bulbous bump and all the flux and everything else off of there. I just have this is a triangle stone, but it doesn't really matter. It's the type of stone that's more so important than anything else, and that's just so that it's actually able to go ahead and stone a high-speed steel. And all we're doing is we're taking kind of that black surface off of there and making sure that the edge is crisp and free of any burrs, and we're just hitting each side here of the cutter. Okay, now let me see if I can. Alright, alright, I like that, huh? You see that? It's just my surface on there is, I brushed it on the stone there as we brought it out here, so we have a nice crisp surface there, and I can go ahead and I can align this edge here with my square off of the table, right like that. Alright, so then I know that this is square. Alright, we're going to go get this set up in the machine. I'm going to show you how to set this in and get it square, and also create a center to center alignment, tool to part. So what we're going to do is we want to go ahead and align these two to each other. Now, I can't do it with putting our tool bit that we're going to use in there. So the one that we decided that was a spare, we're just going to put that in here so it represents the round shaft, which our bit is center of that. So all we need to do is create center of this, and that would be exactly but in line. This is already lined up to the table, and this is already lined up to the axis of the table as well. Alright, so we got this. We're going to pull our part out of here. Safely out of the way. Alright, and then we're going to go ahead and we're going to put an indicator on here. And put it something like that there. Now I'm going to reach over here, and I want to try to get an indicator to where it's either 100% yeah, facing away from us or facing towards us. Okay, and it looks like we're going to have better luck on this right here. Okay, after we have this locked, then we can pivot the axis of the indicator so it's straight in line, and it has a little bit of tilt there, but it's not extreme. Alright, we're going to grab our mirror. because we're actually going to be looking at it this way here, and alright, and we're going to go ahead and we have this up out of the way, and we can go ahead and swing this around, and we're lucky we didn't hit the table. And what we're seeing here is we're actually got clearance in there, so we need to crank the table up. Okay, and we're probably going to have to slide this in closer to the center here. I'm just eyeballing it, a quick eyeball on how much it goes in and out. Okay, now that I know I'm close. I didn't know where I was to start with. Okay, so we got 0 there, and we're like plus 45, and then back up to our 0. Over here we're like 10 or 20. Oh, it might be just off up and down. Okay. Alright, we're gonna go there. We're gonna set that at 0. And we're coming around at 0. -1. +1. Alright, now my tables and stuff aren't locked all the way here, so the knee is pretty good. The knee, I always kind of keep it kind of snug anyway. Okay, we're plus, so we want to come back here. Alright, there's 0. We're 0. Minus a quarter or so, like 2/10. 0. And about plus a tenth. We're going to leave it right there. I mean, we're going to call that 0. Also, with the brake on and our hand wheel going in, we're going to turn the dial to 0. And what I usually do is just put that on there so I know all the backlash out on that side of the wheel. Alright, just so you can see what I'm doing, I went ahead and I set this, and I got the gauge or lever hand wheel engaged with the weight dropped off that side so that I know it's holding that backlash there. I set that at 0, and I'm going to go ahead and set this one at 0 as well, because this is 0 as far as up and down center, although we will be changing that. We might actually be, once we're touched off, we're going to be using this to increase our depth as well. We don't need to know in and out yet, because we are going to be moving the table to set this up. But right now we're up in line 100% with this dividing head and the cutter itself. Alright, now we're going to go ahead, before we put our part in, we're going to go ahead and put our real tool bit in here. We're going to set that square. And we are just going to go ahead, we're going to operate this in the vertical, so we're going to be cutting on the bottom of the bore. We'll be able to stare in and actually see it a little better. I prefer that, or on the back side, but with it set up like this, it's very, very easy. Alright, now we're just going to go ahead and we're just pivoting this side to side, and we're holding our square down against the table here, and that right there is square. We went ahead and tightened this down. We verified that we have square tool bit on both sides. Now we're going to go ahead and put our part back in. We're going to add a little die. We're going to start setting up to make this index create 14 different spots for the splines to put the splines in. Alright, we're going to go ahead and we're going to put our part back in here. And we're nice and clean on there. And we got to bring this back up here. Alright, now that we're center here and we've got the tool bit in here, we're going to go ahead and we're going to fire it up, and we're going to set our in and out stroke here. But we're going to paint up the bore here first because we want to kind of see that.